The first question that I have is, how many of you have been working with WebRTC and done things with it? Okay. Out of the things that you've done, how many have actually tested the things that you've done? Okay. How many of you have set test automation on the things that you've done with TestRTC? With WebRTC, sorry. So that's like the usual crowd that I have. People building stuff with WebRTC, happy that it works, they go to production, then it doesn't. It doesn't because they didn't configure a stun server to begin with, or didn't put a turn relay and then customers complain. Because they didn't really test. So the first thing you do, you bring in a tester that would do this manually. And then you get these conversations with people and ask, okay, so how much, how many people can you put in a room? They said, well, we don't know, 16. How did you decide on that number? That's the number of machines we had at the office. Okay? So a lot of the testing in WebRTC is done manually. And I'm here to show at least what you can do to improve that. My name is Tzachi Levent-Levy. I'm the author of blog GeekMe and the co-founder and CEO at TestRTC, a company that deals with testing and monitoring WebRTC-based applications and services. And I want to start with this. That's where I come from. I come from the voice over IP domain. That's what I did in the last, I guess, 20 years already. And WebRTC comes and sits somewhere in between voice over IP and the web. They both run over IP, but they do it very differently. They come from two different disciplines. And somewhere in there, you throw WebRTC into it, and things start to not work or behave or being understood that well. And I want to focus at that area between voice over IP and the web as it relates to testing. Okay? And it affects testing in 5 main ways. The first one, WebRTC is a brand new technology. Not only that, it is browser-based. We have it running inside the browser. Not only there, but that's where we have it as well. Then it's resource-intensive and network-sensitive. And these two are quite a headache when it comes to testing and understanding the behavior of what happens with a WebRTC session in real life. Last but not least, and we'll see that later, it takes 2 to tango. And that's very different from how you test things over the web today in most of the cases. So let's start. If you think about WebRTC, it's here for 5 or 6 years. But only in the last year or so, we've seen changes in the Chrome browser. Okay, a lot of changes there that have happened that affect the way your applications are running. The jitter buffer has been replaced in the Chrome browser, just a total rewrite. Some of the media servers out there failed to make the changes. They needed to be modified. A new echo canceller is coming out soon. It should have been, but it hasn't gone out yet. It's going to be integrated soon enough. And that's like the 3rd or 4th iteration of an echo canceller inside the Chrome browser for WebRTC. We've got new APIs in the form of add track and remove track. GetStats moved from the implementation that we had. GetStats is the way you can take out of WebRTC using JavaScript in your code the statistics of the session and then doing something with it. Okay, so the API itself has changed. It has been modified because the standard decided to define it differently than how it was written and implemented in Chrome. And that's, again, broke some of the implementations. And then we've got unified plan. There is something called Plan B, and there is unified plan. There are both different ways of how you configure and express the way you're going to support multiple sessions or multiple channels, multiple media channels in the same session. And that's going to change as well in Chrome soon enough to be more standard compliant. But these changes are going to affect whatever it is that you are doing. Now, on top of that, we've got new browsers. Edge and Safari coming out with the WebRTC support. And guess what? It doesn't really work out of the box with other browsers when you're actually starting to tinker and do the more advanced stuff with it. It breaks. And things are going to change and improve, but that's where we are today. We've got changes that happen inside the browser itself all the time. We've got new browsers coming in, and we've got additional new technologies. If you write something with WebRTC, you're probably also going to use something like service workers, WebAssembly even, okay, Web Push, WebVR, or other technologies that are quite new to the browser as well. I've seen, for example, a company using WebAssembly to decode Opus. They needed an Opus decoder running on Safari. Safari doesn't have Opus, but it has WebAssembly. Okay, so they built a whole implementation of an audio decoder in WebAssembly and run it inside the browser. And these are the types of things that you are going to confront with and work with when you build things with WebRTC today. Now, WebRTC is browser-based, so we've got a browser, and then we've got our web application. We did these things over the web up until today, but then we need to deal with signaling. So we're going to add a signaling server into the mix, or maybe have it coupled up with a web application, and that signaling is going to be whatever we decide it to be. It can be SIP over WebSocket, it might be XMPP, or whatever it is we fancy. Usually, it will be a proprietary implementation of one sort or another that just met our needs for that specific job and topic that we had to do. So we've got two components, and then there are stand and turn servers that handle NAT traversal. We need to deploy them, preferably as close as possible to where the user is coming from with his browser. Okay, that's another moving part. And if we're putting something in production, there's a very high chance that we are also going to have media servers in there. If we need group calls of multiple people, it doesn't work well in Mesh. We need a server for that. If we want to record the sessions or do some other server-side processing to the media, we'll need a media server. Now, we control all that. Okay, we decided the tools to use. We selected the frameworks, open source, commercial, self-developed, whatever. We've deployed, and we're running this in production. We've tested it. We're happy with the fact that it's working. There is one piece of software that we are not going to control and we can't control, and that's the browser. Okay? In the span of a year, that's the number of version changes you will have for Chrome and Firefox. Every 6 to 8 weeks, every 8 to 6 weeks, there is going to be a new version of the browser. And guess what? They're not going to ask you if that delivery date for the browser is good for you or not. They're just going to deploy it. And then your customers are going to run the latest version of the browser. And if you haven't tested against that, your service might stop working in a single day for all of your users that come in from a specific browser. And it happens. Okay? Now, these changes can also kill things that you're doing on mobile applications. So if you have a service that runs on both a browser and inside a mobile application, then they need to talk to each other, and the browser changes the code, and that code behaves differently, then this application of yours might not communicate with the browser. This also happens. It happens a lot because people take the WebRTC code, port it, put it inside their own application, and they forget about it. But the WebRTC code continues to improve and change, and then something is done that kills past behavior, and your service stops working, and you have no clue why. Okay? So that's the fact that WebRTC is browser-based. You don't control everything in what's going to happen in your application. WebRTC is also resource-intensive. If I need to go of the different resources we have in a machine, we've got CPU, memory, network, and storage. When you go and look at WebRTC and what it does to the CPU, at least on the browser, well, it burns the CPU. If you are trying to use a video session in WebRTC and you do 720p, for example, you are going to burn the CPU by the amount of processing power you need to encode and decode the data. And moving to newer and better codecs, to higher resolutions, to higher frame rates. On the memory side, it's going to eat up the memory for the same reasons. If we're encoding a lot of data, we need to process a lot of data. We need a lot of memory for that. And we're going to eat up the network. And we're going to do that a lot more than we're doing with anything else inside the browser today. Okay, web pages today are what, an average of 2 megabytes. That's what we're going to download. They tell us that that's a lot. You're going to be consuming a lot more than that with any WebRTC session that you just sit and wait for a few minutes. You don't just fire it up, get connected, get the page, render it, and that's it. That's the whole amount of network that you are going to use. As long as the service is open and you're running with it, you are going to consume data. And that's going to affect the way that you need to deal with testing. I've seen a service recently that what they do is they allow you to do automated, large-scale testing for a web-related type of product. And the way they build it is they say, you know what? We're going to do this. We're going to put 100 browsers on a 10 vCPUs machine, virtual machine with 10 virtual CPUs. It doesn't work for WebRTC. What we do at TestRTC requires something roughly in the vicinity of 1.8 vCPU per browser to run well with a single session of audio and video. Okay, so the whole mathematics of how you do things becomes different. I can also not say, well, we're going to start this call, we'll wait a second, we'll start this call, and we'll use the same machine. Because that first one is still running. It's still eating up CPU, memory, and network. So the whole way we need to think about the resources that we're going to use and expand for doing testing is totally different than anything else that we had on the web up until now. On the other side, WebRTC is network sensitive. It doesn't use TCP, it runs over UDP, and it deals automatically with things like packet loss, packet duplication, reordering of packets, jitter, a lot of things. You don't need to worry about that, right? It's just, it works until it doesn't, okay? And it doesn't work because of several different reasons. First of all, if you have a media server, then someone is in charge of the implementation of that media server, okay? Now that data is going through a network. Someone needs to manage and maintain that network. You can't do that for the internet, but you can decide at which point will that user enter your network, okay? And you can try to make it as close as possible to the user. You're in charge of the links inside the data center or from the data center and out, of how you scale the machines that needs to deal with that information. Okay? So there is a difference in where you locate the machines and where the users come from. Things that you test in the office will be different than things that your customers are going to experience when they run from different locations. And the great thing about WebRTC, it's global. Okay, that's how web developers think. We deploy, it runs globally, we put a CDN, and that's it. We don't deal with load. We don't need to think about load. Everything that is a static resource, we put over a CDN. Nothing in WebRTC is static. There is no CDN. You can't use a CDN. CDNs are starting to use WebRTC, but they are doing it to reduce latency, not to support live conversations or the type of interactions that we're trying to achieve with WebRTC in communications. You need to factor all that in when you develop, later on when you test, and when you monitor. Last but not least, it takes two to tango. If I need to check a web application, I need a user. I take the user, he's going to do something in front of the server. That's it. Now I want 1,000 users. So I take that user, copy paste, got 1,000 users, and I'm happy. But if I'm doing a WebRTC application, that user is not going to sit there and do something with the server. He will need someone to talk to interact with. How is that going to happen? Is that me and you going to the same URL? Is that you deciding on some random URL and you're going to tell him that URL somehow and you're going to meet on that URL? Are you going to log in and he is going to wait until that happens and then he will call you and then you're going to answer? Okay, so there is some kind of a synchronization mechanism that needs to happen here across browsers within the same scenario, within the same test. It's not that scripting something in a single browser, forgetting about it, and then scaling it up. It doesn't work. It becomes even harder when you're doing more than two inside the same session. How do you now take these 4 users and decide to scale that into 200 users? How are you going to split them between the different rooms where they are going to converse? How are they going to interact and synchronize inside that room? Who is going to be the one in the room, for example, that is going to screen share or to mute or do whatever it is that you want him to do within the scenario that you are testing? So we've got these servers on one hand, the whole infrastructure that we build, and we've got browsers that we want to use as our minions to go into the service and test it. How do we actually do that? The first thing is, well, Selenium. We like open source. We're going to use Selenium. Selenium allows us to take browsers and to automate what they are doing. So we use Selenium. You probably Selenium grid because we want to run more than a single session. And we're going to do it locally because that's easier, it costs less. We won't be able to scale that, but that's what we're doing. The next thing that we'll need to do is to think very well how we're going to schedule the use of resources that we are going to use. Are these machines going to be deployed all the time, just waiting for us? Are these machines going to dynamically come up when we need them? How many browsers are we going to cram into a single machine? What's a machine? How much bitrate and bandwidth do we need to be able to support in that single machine to run our scenario? So we've gone through that hurdle. The next one is we'd like to control the network. I want to be able to enforce the browsers to go through a turn relay. Why? Because otherwise, how am I going to check my turn deployment? I want to decide to, let's say, add packet loss, see what happens. Reduce bitrate, increase bitrate. Do that at the middle of the call. Decide on adding latency. I don't care what Chrome browser does, that's fine. If the only thing that I'm doing is peer-to-peer, point-to-point, that's fine. But if I'm going to have a media server somewhere, then these are things that I need to test and I need to check. Next, I need to be able to synchronize across browsers. Okay, we said someone logged in, the other one logged in. How do I know here that this one already logged in so I can dial him? Who tells me that fact that this actually happened? Okay, so we built some synchronization mechanism between the browsers out of the scope of Selenium and everything else that we're doing, and we're fine. And then the last thing, we actually need to understand WebRTC. Okay, I've got Selenium. I've built a session with 1,000 browsers in it. They all go and hit my media server. Everything looks great because I'm not looking at any of the machines. Okay, I just look at the server. The server seems fine. He's not burning his CPU. He's not even using it because that's an SFU. We route media around, so the CPU isn't even hurt by building an SFU. But the network is dead. Nothing works there. Something does, but is it to the level of the criteria that you've selected? Okay, so these are things that you need to be able to do. And so we did an exercise at SRTC a few weeks ago. We've taken Currento. Currento is one of the most popular open source media frameworks out there. It's very generic. You can do almost everything with it. It got acquired by Twilio. Still open source. So we've went to one of our partners, WebRTC Ventures. We told them, you know what, let's take a machine on AWS, because that's like where people host stuff today. You install Currento on it, and we decide on 3 different use cases on that specific machine, nothing else. We're going to do a one-on-one call that is going to get recorded locally by the Currento server. So we've got a Currento machine, one browser here, connects here, another browser connects, and we just store the session. Second one, we want a full-wave video call. And that call, we want it to run on an MCU. MCU means that we're going to mix data. 4 browsers are coming into the server. The server is going to decode the video of all 4 browsers. He's going to look at these resolutions, say, that's too big, scale them down, compose a single layout with all 4 videos in it, encode it, and then send it back. So now we're going to burn the CPU, just for the fun of it, and see what happens. And the third was, let's do live broadcast. Everybody live broadcast today. Let's try that. We have one person that is going to send his data into Currento. All the rest are going to view. And we asked a single question in all three scenarios. And that question was, how many browsers? When is this thing going to break? Okay. And I want to show you the results that we've had. So this is, I'm going to do that on test.rtc just because that's where we executed it. To give you an explanation of what we do, I'll just do something really quick here. I'll go to the tests. Let's select a demo that I did recently. That's a demo of a 4-way video call. Okay, it runs, this specific test runs on Jitsi. Popular, public, the first user logs in, clicks to get whatever room that he wants. Okay, click the enter room button. Then the URL that he got is an ad hoc URL, a random one that was created for this specific session. He's going to send that URL using the RTC set session value to the other users. And all the other users are just sitting and waiting. And when they get that URL, they're going to do URL, just join the URL that they received. What they will do next is just run for a full minute, wait, take a screenshot in the middle, and that's it. So what we're going to do now is just run that. And we're going to run it, of course, out of 2 different locations. We're going to run the test. We're not going to wait for the whole results, but what you see here is 4 machines are now running over Selenium with everything that's there is. 3 are waiting. 1 is starting. He's actually going, clicking a button, waiting for the other page to come, for the URL. When that happens, he's going to open a page. That's like the URL, and you see the random part in there. And then the rest are going to join him. I'm not going to wait for them. What I'm going to show you now is the results that we've had with Currento, because that was really interesting to me. And we'll start with the one-on-one testing. Okay? So the first thing we did was, let's find that, we've established a baseline. How do you do that? You say, I'm going to run the smallest session possible to users, going to see what happens. And I'm not going to drill down to the results from each browser. That's interesting, but I don't have time for that. But we look at the high-level charts in each and every such scenario. Okay? So Currento out of the box does 500 kilobit per second for the video session. The line is straight. It seems fine. We've got a baseline. Next thing we said, let's scale it up. And let's try to find something with something like 20 or 30 users. The 31 was nice. Let me find it. Where is it? So we use 30 users. They all succeed to connect. They all send and receive media. We're all happy. But now it looks slightly different. Okay. What you see here, the pin colors, shows the differences between the minimum and maximum average across all the browsers that were used for the test. So we've got 30 browsers. Some of them has had, a minimum below 200 kilobit per second. So something is wrong here. To check that out, we're going to look by probe. And what we see here is that 4 of the browsers here, are doing rather bad now. So what happens? We've got a server of Currento running one-on-one sessions, 30 of them. 4 of the browsers, so anywhere between 2 to 4 sessions, are experiencing some bad quality if you compare it to the rest. If we look at the numbers, that's 22, 4, 28, and 6. That's 4 different sessions. Otherwise, they would have been consecutive, 1 and 2, 3 and 4. Okay? If we go from bitrate to packet loss, then, well, a surprise. We've got incoming packet loss for 4 different users. Okay? Now we can start playing. I can decide to improve the network, check the server, see if the problem is in the storage part, decide to say, hell, 30 is too much. I'm going to try 20 and see what happens. The end result was that between 18 to 16 is the actual number that we could have done on that specific machine. But the server broke in a very, interesting way. Okay, it didn't scale everything down. you just killed some of the sessions. Now, if that was a network issue, you would have seen all the sessions suffer. A network issue on the server side, or where we placed it in our server farm. We've had that with another customer using Curento before he launched. So now let's go and look what happened with a four-way call. Okay, so four-way call, let's find our baseline. Four-way call, baseline is 4 users. Okay, still 500 kilobit per second, a bit more jittery, but okay. Let's find a four-way call with 20 users. 20 seems like a nice number. Okay. What do we do now? Again, we've got an issue of things being too jittery, jumping to 1 megabit, going down to 0. And again, if I go to by probe, I can see that they are suffering here, but not much. So something isn't quite right, but I can't say what. And we've got these huge packet losses in some of the users. So something is wrong with whatever it is that we are doing. Okay, the server is suffering in some way, and we need to check why. But it is suffering in a totally different way. What we've seen when we ran 4 sessions in parallel, for example, in one of the tests, it's like only 4 browsers didn't work well. The only problem was that each and every one of these browsers was from a different room. So all 4 rooms that ran in the server didn't work well. So it was spread all over. Same machine, different scenario, same software, totally different results. Now let's look at the broadcast, because broadcast is something that people like doing today, and broadcast gives us the ability to go higher in the numbers. So I called it a webinar. And again, I think that was yes, that's a benchmark. So the benchmark, 500 kilobit, we've got this line because one of the users isn't sending data, the other isn't receiving data. They're doing it only one way, each one of them. Okay, but that's our benchmark, straight line. Let's see what happens when you scale this up to a nice number. Let's pick the nice number 150. Okay. Something went wrong here as well. Okay, but it's different. If we go and look by probe, you can now see that it's sloping down nicely. Okay, so things, and it shouldn't, because I'm sending the same media stream to everyone. Everyone should receive the same thing. If they don't, there's either packet loss or something went wrong along the way. We can check the packet losses as well. No packet loss. So the server is doing something wrong. We can take a fail test, for example, just to see what it means to fail, at least with TestRTC, without adding any configuration. So I did the same with 200 browsers. You get results, like 94% of the calls got connected with media, the rest didn't. Okay, so we've got, like, if you go down, there are some 12 browsers here that didn't get media at all. I can try to drill down, understand what happened there. Was that signaling? Was it media? Something else that happened? Again, I can check to see the slope that we've had. So the thing is, and this is what I found, and for me it was interesting, I mean, I knew that if I took the same machine, same Curento, and just replaced the scenario a bit, did something a bit, I totally changed it, okay? The actual numbers for the server would be different. So for the one-on-one call, we got something like 16 to 18 browsers. For the four group calls, we've got 16 browsers, or it was 12, 16 was flaky already. For the broadcast, it was somewhere between 100 and 150, but it smelled to me as if something was wrong in the way that we've configured the server, that it required more, let's say, hands-on to see what's wrong there before we could move forward. It wasn't stable enough, probably on the signaling side, not on the media, because sometimes things got connected, sometimes they didn't. And you see that happen a lot. What I didn't expect was that different scenarios fail differently. It's not as if going with Currento with one way and broadcast failed in the same way. They show different behaviors in how they fail. Okay? One fails by just killing all of the sessions and making sure that everyone suffers the same. Others are going to just silently kill some of the things that you are doing. So it's very important to understand that you're not looking for a single behavior across everything. You can run a test with 100 browsers, put then a QA tester that runs his browser, everything will work for him, but somewhere along these 100 browsers that have been automated, things go wrong. And they're not going to complain if you don't tell them to complain somehow. That's what it means to understand WebRTC. Now, when to scale and how to scale is actually a very hard question to answer. And I don't really have a good answer. It can be a number. I know that that machine for my specific workload can do 100 streams. But what if I change a bit the things that I'm doing? I want a bit more resolution, or I'm going to put more packet loss into the network. Would that number change because of the thing that I just did? Would the server work harder? Okay, some servers will say, you know what, we don't care. If you're looking at the CPU, by the way, of the machines on the media servers, to decide when to scale, you're doing it wrong. If you're doing it anywhere near something that makes sense, it would be through bandwidth. How much media it gets processed through it, especially if that's an SFU, a machine that routes media. Okay, again, because the CPU isn't used there. And answering when and how to scale is hard. You need to find that point and fine-tune it for your specific use case. And that's not easy to do. And for that, repeatability is very important. The ability to take a test, especially the large-scale ones, being able to run it once, twice, 3 times, look at the results, change the configuration on the server, change the code, redeploy, run it again, see the results, compare them back to what they were earlier, are things that are just important. Doing that with humans and manual testing is just impossible. So whatever you do at scale, make sure that you automate your testing as well for that. Thank you.